All right, number 5 here, it says, find the slope of the tangent line to y equals arc sine of x squared at x equals 1. Well, we want to do the derivative in order to find the slope of the tangent line to a curve. So, y prime. So the derivative of arc sine, we know is, we know it's of a fraction. So we can think of x squared over 1. And this is 1 over the square root of 1 squared, what the denominator is, minus u squared, which is what the numerator is. So it's x squared squared. But however, since it is another function, x squared, this is a chain rule, so we have to multiply by 2x. And so the derivative is 2x over the square root of 1 squared minus x to the 4th. And then we're supposed to evaluate this at x equals 1. So it looks like it is going to be undefined here because we'll have 2 times 1 in the numerator. But in the denominator, we'll have the square root of 1 minus 1 to the 4th, which is 0. So this is undefined. All right, moving on to the next one. A conical water tank with a vertex down has a radius of 30 centimeters at the top and is 40 centimeters high. Water flows out of the tank at a rate of 50 centimeters. That should be 50 centimeters cubed per second. How fast is the radius of the water decreasing when the water is at 16 centimeters deep? So that's interesting. So it gives us the water level, not actually the radius. So we'll have to work with that. So if you want to draw a quick sketch of this, you can. The radius is 30 and the height is 40. All right. So we know volume is 1/3 pi times r squared h. That relates the volume because we're given dv dt. And we want to find dr dt, find how fast the radius of the water is decreasing. So we don't want this h in here. So we have to find a relationship between r and h. Well, over here, if we think of water in this tank, we'll just put it down here. We have, here's our r, here's h. So we want to solve for h because that's the one we want to get rid of. So let's do h over r equals 40 over 30. 10s cancel, multiply both sides by r, and you get h equals 4/3 r. So we are going to substitute that into our formula. So this is 1/3 pi r squared times h, which was 4/3 r. We'll simplify that. 4/3 times 1/3 is 4/9 times pi times r cubed. And now we want to differentiate. So we have dv dt is going to be 3 comes out front, cancels with a 9. So this is actually to 4/3 pi r squared dr dt. And now we should be able to plug in. We want to find dr dt. So dv dt is negative 50 equals 4/3 pi times r squared. Well, we actually don't know r squared. We know the depth, but we can find that. So we actually can come down to our little ratio here. And if we know the height is 16, we can say 16. We could actually do a couple things. We could bring, actually, this is probably the easiest. So let's come over here. H over r equals 4 over 3. We know our height is 16. So what's the radius? A couple different ways to solve this. But let's just say we'll cross multiply. 4r equals 48. So r equals 12. So we want to put 12 in for r. And that will help us find dr dt. And then we follow through with solving this. So negative 50, 4/3 times 144. Forgot to write the pi in there. Dr dt. 3 goes into 144 48 times. And 4 times 48 is 192. So we have negative 50 equals 192 pi. What I was writing over here. Dr dt, and divide both sides by 192 pi, and we get dr dt equals negative 50 over 192 pi. And that would be in centimeters per second. All right, we have a ball is thrown from the top of a building that is 15 meters tall with an upward velocity of 15 meters per second. Develop the velocity and position functions for the ball. Well, we know the velocity function is simply the derivative of, let's start with the acceleration function, which is negative 9.8. The velocity function is the integral of the acceleration function. So this is negative 9.8 t plus c. Well, we know the velocity is 15 meters per second initially. So we have 15 equals negative 9.8. So initial velocity means time is 0. So c is 15. So our velocity function is negative 9.8 t plus 15. And then we can find our height function by taking the integral of the velocity function. So that's negative 4.9 t squared plus 15t plus c. But we know that our initial height is 50, which initial means the time is 0. And so c is 50. And so the height function is negative 4.9 t squared plus 15t plus 50. How long will it take for the ball to hit the ground? Well, the ball hitting the ground is when the height is 0. So we want to just plug in 0 for the height function. So there's our height function. Here's our velocity function. How long it take to hit the ground is when the height is 0. Well, this is a quadratic equation, so we can use the quadratic formula. So t equals negative 15 plus or minus the square root of 15 squared minus 4 times a, which is negative 4.9, times c, which is 50, all over 2 times negative 4.9. This will give us two answers. However, we're just going to want the answer that uses the negative, because we'll have a negative over a negative, which is a positive, and we'll need that when time is positive. And so we could plug this in. Let's see, we can do the whole numerator. So we'll do parentheses, negative 15. We're going to do minus square root of 15 squared, which is 225, minus 4 times negative 4.9 times 50, end parentheses, divided by 2 times negative 4.9, so divided by negative 9.8. However, I'm going to tell you something. If you're going to try to put the whole thing in here, make sure you put divided by parentheses 2 times negative 4.9. Otherwise, it will do the division first, divide by 2, and then multiply the answer by negative 4.9. So make sure you put parentheses as necessary, and this is 5.07 seconds. What's the maximum height of the ball? Well, when we see maximum height of the ball, that means the ball is going up, coming to a stop, and then going down. So that's when the velocity is 0. So we're going to make our velocity function equal to 0. So negative 9.8t equals, minus plus 15. Add 9.8t to both sides and divide by 9.8. So we have 15 divided by 9.8. The time at which the height will be maximum is 1.53 seconds, but it says what is the maximum height, so we now have to plug that into our height function. So height, that's negative 4.9 times 1.53 squared plus 15 times 1.53 plus 50. I'm just going to go ahead and put that in the calculator. In fact, I'm just going to use this previous answer here. So we have negative 4.9 times our previous answer squared plus 15 times our previous answer plus 50. And the maximum height is 61.5 meters. All right, the spring constant for a spring is 1.3 newtons per meter. Find the work done in stretching the spring from 2 meters to 4 meters. These are very easy questions if you know what you're supposed to do. So work is simply the integral from 2 to 4 of 1.3x, and we integrate. You can integrate just by working through this. So this would be x squared. The half comes out front. Half of 1.3 is 0.65. Evaluate it from 2 to 4. And so we get 0.65 times 4 squared minus 0.65 times 2 squared. And we can figure out what that is. So you can use your calculator now. You could have used your calculator before. You could actually just keep thinking, well, I have 0.65 times 16 minus 0.65 times 4, which means we kind of have like terms here. We could factor out the 0.65 and do 16 minus 4, which is 0.65 times 12, and then you can multiply it. So different ways to get that 0.65 times 12 is something. And our last one, find the quadratic function. So quadratic function, f of x equals ax squared plus bx plus c is the quadratic function that includes the point 3, 0, and has a slope of -8 when x is 0 and a slope of 0 when x is 2. So this one just has to do with the original function. It includes that point, or it passes through that point, so we know when x is 3, that this is 0. And so we have 0 equals 9a plus 3b plus c. So that's the first, using this point here. These next two have to do with the derivative. So let's find the derivative of our quadratic. So that's going to be 2ax plus b. And so we know the slope is -8. So using this one, the slope is -8 when x is 0. Well, that automatically gives us b is -8. And then the slope is 0 when x equals 2. So the slope is 0 when x is 2. So we have 2 times a times 2 plus b. So 4a plus b. And now we can start solving. We have b equals -8. We'll put that in here. So 0 equals 4a plus -8. We'll add 8 to both sides. So a equals 2. A equals 2. We'll now take both of those and put them in here to help us find c. And so what do we have here? We have 0 equals 9 times 2 plus 3 times -8 plus c. This is 18 minus 24 plus c. So this is -6 plus c. Add 6 to both sides. We get c equals 6. So our answer is f of x equals 2. So we're putting it back into our quadratic function, 2x squared minus 8x plus 6.